Hey everyone. So, what if our coastal defenses weren't just these huge, lifeless walls of concrete, but were actually living ecosystems that got stronger over time? Well, today we're looking at an idea that does exactly that. We are talking about a breakwater that actually breathes. For centuries, the way we've protected our coasts has basically been a battle. We've been fighting the ocean, right? Building bigger, stronger, more expensive walls. But here's the thing. That's a fight we are starting to lose. This explainer is all about a huge shift in that thinking. What if, instead of fighting the ocean, we actually partnered with it?
Okay, let's dive right in. The reality is our coastlines are facing a kind of two-pronged attack. Sea levels are rising and, at the same time, storms are getting way more powerful. And all this is putting this incredible pressure on our old static defenses. And frankly, they're starting to crack.
And this really gets to the heart of the issue. Concrete breakwaters are static. They're basically frozen in time. They can't grow, they can't adapt as the sea level rises, they cost a fortune to build and maintain, they create these ecological dead zones, and maybe worst of all, they just corrode and wear out over time. It's a temporary fix for what's become a permanent and growing challenge.
So, if these static walls are the problem, then what's the solution? This brings us to a really radical new idea, a total paradigm shift. A coastal defense system that doesn't just sit there, but one that actively grows and makes itself stronger. This is the living diamond reef. And the concept? It's as elegant as it is powerful. It's a coastal shield that's completely corrosion-free. Why? Because it uses biology, not metal, for its strength. It's a structure that is literally using life to protect life.
So you're probably wondering, how on earth do you build something like this? Well, the amazing answer is, you don't really build it, you just kickstart it. You put nature's own toolkit together and just let it get to work.
Okay, let's walk through how this thing actually works. The life cycle is just so clever. First, a really lightweight starter frame gets floated into position. Simple. Second, it gets seeded with a very carefully chosen team of organisms. Third, and this is the magic part, those organisms start to grow, weaving themselves into the frame and eventually taking over all the structural work. It literally evolves from a simple frame into this complex habitat that, as a huge bonus, actively filters the water around it. So let's meet the construction crew. The starter kit itself is made of sustainable stuff, like woven bamboo and a biopolymer, which is basically a biodegradable plastic. But the real engine here is the mangrove roots. They form this incredibly dense and strong living mat. Then, hanging below them, you've got kelp or other algae on these things called drop lines, and they act like giant carbon sponges. And woven into the whole thing are mycelium pails. That's the root network of fungi, creating this kind of honeycomb of tiny habitats for all sorts of other marine life. And this handoff from a man-made frame to a living structure happened surprisingly fast. In just the first 6 months, those mangrove roots start to mesh together. Within 2 years, that root mat thickens up a lot, and a biogenic carbonate shell starts to form. You can think of it like a natural cement made by the organisms themselves that hardens the whole thing up. And here is the absolute key. In just 3 to 5 years, over 60% of the structural load is being carried by living tissue. The starter kit has done its job, and it's handed the work over to nature. But this system is designed to be more than just strong. It's designed to be smart. It's an intelligent, adaptive system that has very clear performance targets and, this is so important, it has built-in backup plans. So, what are we talking about performance-wise? First, the reef is designed to grow upwards by at least 5 centimeters every single year. Now, why is that number such a big deal? It means the reef can literally grow to keep pace with rising sea levels in a way that no concrete wall could ever hope to. It also cleans as it protects. There's an integrated rotor system designed to pull at least 2 tons of microplastics out of the water every year. That's for every 50-meter cluster. Pretty amazing. And it fights climate change head-on. Between all that mangrove growth and that natural carbonate shell, the system is designed to lock away at least 150 tons of CO2 over 5 years, making it a true carbon sink. Now, this all sounds incredible, right? But hey, we're dealing with biology here, and biology can be, unpredictable. So the question you're probably asking is, what happens if things don't go exactly to plan? This is where the intelligent design really shines. The whole system is designed to learn and adapt, with clear backup plans. The goal, the ideal, is Pathway A,
where biology does all the heavy lifting. But if the system is underperforming, pathway B kicks in. You can add structural supports to give nature a bit of a helping hand. And if growth just stalls completely, pathway C allows for a temporary biocomposite core to be installed, providing support until the living parts can recover and take over again.
So the key takeaway here is that this project is aiming to be so much more than just an engineering solution. The goal is to actually transform coastal defense into a source of ecological and economic abundance for the communities it protects.
And to make sure this can work anywhere in the world, the plan for monitoring, reporting, and verification, or MRV, is tiered. The light tier uses really simple, accessible tools like drones and depth sticks, which is perfect for communities that don't have a lot of resources. Then the mixed and full tiers add more advanced scientific gear for research sites. It ensures the whole model is adaptable and scalable for everyone. And this, right here, this is the final piece of the puzzle: the community. The system is designed for local stewardship right from day one, with super simple maintenance that can be managed through a mobile app. But it goes way beyond that. It actually creates economic opportunities through shared revenue from things like seaweed harvesting, from the sale of blue carbon credits, and even from new ecotourism. It's all about empowering communities to protect themselves while building a sustainable, local blue economy.
All of this leaves us with a really provocative thought. For centuries, we've built these massive, static, lifeless projects to defend ourselves from nature. But the living diamond reef asks a totally different question. What if our greatest and most enduring infrastructure projects weren't built, but grown? What if they were alive?